I hope you're all enjoying your day off. We are on video 2.8, comparing distributions. Get your notes ready. This is going to be more of a analyzing and writing video than it is so much of learning a new process video. So the first thing we need to look at is how to compare histograms, and we've done this a little bit, but we're just going to go deeper into it, especially with the work that you're going to do on Wednesday in class. So our first thing you have to do when you see histograms is analyze them for what they are, what they're measuring. Don't just jump right into the problem. So we see that we have two histograms, and one is for the ages for Kenya. We've seen this one before, and also the one for ages of the U.S. Measures percentages on the y-axis, and that's also our dependent variable, and then our independent variable right here is age. It's the same setup for the one for the histogram of ages for the U.S., but we can see that the scales are much different for the two histograms. This scale for Kenya goes all the way up to 18, while this scale for the U.S. only goes up to 8. And this interval goes by 5s, and each one is labeled, but this interval, while it also goes by 5s, each 5 mark isn't labeled. So you need to make note of that. So let's look at our first question. What percent of the population in Kenya is between 15 and 50 years old? So to answer that question, I have to find 15 and 50 years old on my histogram, and I have age on the bottom. 15 would be right in between 10 and 20, right here, and then 50 is right here. So I need to look at everything in between, and I'm just going to add them all up. And sometimes it's a little difficult to read these histograms because they look like they can go at many different numbers depending on how accurate you are, so we're just going to estimate. So I'm going to start here at 15, and it looks like that 15 bar goes right about up to 10, and I'm going to write that below the line since I have much room to do it above. And then I just look at the next bar because that was only 10 to 15, 15 to 20 I mean, and now I need to look at 20 to 25. And 20 to 25, even though it's a little lower, I'm still going to round and say about 10. For the next bar, I see that it's substantially lower than the other two, so we're going to say that that's at a 9%. I'm going to write it out down here when I'm adding together. I'm adding them together because I want to find the total percent of the population that's in between those two ages. And then I'm at my next bar, which is 30 to 35, and that's right about at 8. Now I'm going to look at 35 to 40, and that looks like it's right about 6. I'm going to round up. If you said 5, if you think one's more than 5, then that's fine. That was 35 to 40. 40 to 45 is at about 4. And then our last one, 45 to 50 right here, let's say is at about 3. And as I'm saying, you can estimate these values. It doesn't have to be accurate. If you're within a range of, I would say, like 5%, your answer is fine and would be acceptable. So all I have to do is add up these values, and we get 50. So about 50% of the population in Kenya is between 15 and 50 years old. And I need to write that in a full sentence because I was just looking over the Common Core regions from January and from June and from August. And they want you to write full sentences explaining yourself. There was one problem even that was just write an entire paragraph like an ELA exam. So we need to really prep ourselves with writing full sentences. So about 50% of the population in Kenya is between 15 and 50 years old. Now that only answers one part of the question. There's also a second question right here that says, what about the same range for the U.S.? So I need to look between 15 and 50 on the U.S. histogram, and that's right about here. And it looks like this is going to be pretty different. But we'll see when we measure. So 15, let's say that's a 7. 20 to 25, let's again say that's a 7. That's like 6.5. Actually, that's more like a 7 too. So we're going to say that that's a 7. And there's a lot of 7s. It's not erasing, so I'll just cross it out. We'll say that's a 7. This one is more of a 6.5, as well as this one more of a 6.5. Now we're back up to 7. This one is like 7.5. Oh, and I've gotten to 50. So, again, I'm just going to add those all together, and we'll get the population, percent of the population of Americans that's between 15 and 50. And that's about 48.5. So I'm going to write in red the population of the U.S. that is between 15 and 50 years old. And I'm doing this for space. You should not abbreviate on your own exams or on your own papers. Is 48.5%. So when I added all these up, it equaled 48.5. So that's actually pretty surprising, because when you look at these two histograms, you don't think they have anything really in common. But when you look at the populations between 15 and 50 years old, you see that they have a very big similarity, that it's about half of the population. The differences in the two histograms comes with the early ages and the younger ages, but those mid-range ages are about the same for both countries. The second question here is, what 5-year interval of ages in the histogram of the U.S. has the most people? So I need to find the highest bar, which is this one right here. So it looks like the most common age to be in the U.S. right now is between 45 and 50 years old. And for our last question, why is the mean greater than the median age for people in Kenya? If you look at this, you see that it's definitely a skewed distribution, and it's right skewed because the tail is right here on the right. And remember, in skewed distributions, the mean gets pulled up by the tail, or if the tail was on the left side, it would be getting pulled down. So the median is somewhere in here within this piece of the data, but the mean is going to be a little bit higher up, because in skewed data sets, and you can write this down, in skewed data sets, the mean gets pulled in the direction of the tail, and because it's right skewed, it's going to get pulled upwards to give it a greater value. And quickly, we're going to compare some box plots. So using the box plot, 25% of freshmen spend less than what time doing their homework? So I know that 25% each of these is 25% each piece of the box plot, and this is the homework time one. Spend less than what time? So I'm going to look at my first 25%, because this would be 75%, and this would be 100%, and going from Q2 would be 50%. So I know it has to be my first 20%, and I see that that answer is 20 minutes right there. Number 2 is, using the box plot, what percent of freshmen watch less than 110 minutes of TV? So I see 110 minutes of TV time right here, and I know that this is Q3, and if each of these pieces is 25%, that is 75% of freshmen. Now, question 3 is, what is the most common amount of time students spend doing homework? What is the most common amount of time students spend watching TV? So remember, in box plots, we need, most common is the smallest piece, the most concentrated. So I see my most concentrated piece here for homework, between 48 and 60 minutes of homework. Of TV, which might be surprising, but may not be so surprising. I don't know. The most common range of data is right here between 0 and 15 minutes of TV watching. So remember, to find the most common, you look at the concentration, and these would be very spread out over a long distance. So your hot question is to look back at the histograms for ages in the U.S. and ages in Kenya. What percent of Kenyans are older than 50? And what percent of Americans are older than 50? I want you to answer those two questions. Put them in your hot question doc. Be ready to do some work with this tomorrow.